Okay, we are going to see if this works. All right, what we are going to do a quick video on is your simultaneous equation. So what you've been working on for the last few days. Okay, so in terms of simultaneous equations, you either have linear equations, so a pair of linear equations. That means your equations have no x squareds, no y squareds, or no xy's. They've nothing strange. They only have 2x's and 3x's and 5x's and 7y's and stuff like that. Okay, how you solve them is you solve by elimination. So you're going to basically eliminate, meaning get rid of, either an x or a y. Okay, and the second type of simultaneous equation you have is a quadratic one. Right, so in other words, one of the equations you have either has x squareds or y squareds, or your two terms multiplied by each other. So by that I mean an xy. And for those ones, you solve them by substitution. All right, so if you look at the sheet I have here, right, this equation, right, this question, sorry, is simultaneous equations. You've got 4a plus 3b equals minus 3, and you've got 5a equals 25 plus 2b. So when you look at these equations, there's nothing odd about them. In other words, there's no a squareds, there's no b squareds, there's no ab's. It's two linear equations. You just have a's and b's, right, and numbers. Right, so to solve this, you're going to solve it by elimination. First off, with this problem is your terms aren't lined up. They're not nice and neat. So what you do is you make them nice and neat. So in terms of that, we will write down 4a plus 3b is equal to minus 3. And then underneath it, we will rearrange this one. So you'd put your 5a minus 2b. So my 2b went to the other side of the equal sign. When it went to the other side of the equal sign, the plus became a minus. Right? Your equal sign. And then I leave my 25 where it is. So now I have a's over a's, signs over signs, b's over b's, equals e over equals, and numbers over numbers. So now I am going to choose one of them to eliminate. In order to eliminate something, I want one to be positive and one to be negative. So when I look at my a's, I have two positive numbers. When I look at my b's, I have a positive and a negative. So I am going to choose to eliminate my b's. How I eliminate the b's is I'm going to multiply the top line by the number that was in front of the b on the second line. I'm going to multiply the second line by the number in front of the b on the first line. All right, so when I multiply them out, I get 8a plus 6b is minus 6. Multiply the bottom line, I get 15a minus 6b equals 75. Now I treat them like three separate sums. So I have no minuses here, so that means these are both positive. So I go 8a plus 15a, so I get 23a. I have plus 6b minus 6b, so that means my b's are eliminated. They are gone. Right? I write down my equal sign, and then I go 75 take away 6. So 75 take away 6 is 69. So I am left with 23a equals 69. So that is the same as a is equal to 69 divided by 23. Right? So the number in front of my a goes at the bottom. So the number in front of the a is the number you are dividing by. So this means a is equal to 69 divided by 23, which gives you 3. You then take this value, your a equals 3, and you plug it back into one of your originals. So if we take the first line, you're going to write 4 times 3 plus 3 times b is equal to minus 3. So brackets mean multiply, so we've got 4 3's, which is 12, plus 3b is minus 3. Right? You're going to solve it, so your 3b is equal to minus 3 minus 12, because the 12, which was a plus 12, went to the other side of the equal sign. So I get 3b is equal to minus 15. So your b is equal to minus 15 over your 3, which gives you a minus 5. Okay? And that is your sum done. And that was one of your Leaving Cert linear simultaneous equations. That one we solved by elimination. All right? This simultaneous equation, right? When you look at it, you have x's and y's is 7, and then you have x squareds and y squareds equal 25. So this one is not a pair of linear equations. This one is a quadratic, right? So for the equations where you have quadratics, you are going to solve them by substitution. How you substitute is you take the equation that does not have x squareds and you will rearrange it. All right? So you rearrange it. You can rearrange it in the form x equals or y equals. So if we go with x, we will get x equals 7 take away y. Right? So my y, which was a plus y, went to the far side of the equal sign and became minus y. Second step is I then substitute. So I sub it in to the second equation, the other equation. So in this case, I am writing down 7 minus y to be squared plus y squared equals 25. So I have substituted my x equals 7 minus y instead of the x. When I write this down, do not fall for the trick. 7 minus y squared is not just you square the 7 and you square the y. It is the same as 7 minus y times 7 minus y. Alright, so when you're squaring it, you will get 49 minus 7y minus 7y plus y squared. So do not forget about these two things. Okay, so that's for this bit. I still have my plus y squared. I still have my equal sign. I still have my 25. So if I just make sure I add them in so I don't forget them. Then you tidy it up. So when I tidy it up, I get my y squareds together. So when I do that, I get 2y squared. I get minus 14y. And I get plus 49 is equal to 25. Right? Tidying up again, this 25 will go across the equal sign and it will become minus 25. So we have 2y squared minus 14y plus 49 minus 25 equals 0. Tidying it up further, you get Okay, so now you have a quadratic equation. In terms of a quadratic equation, when I look at this equation, I know that 2 can go into everything. So I have the option of dividing the whole line by 2. So I have smaller numbers to work with. So if I divide by 2, I get y squared minus 7y plus 12 is equal to 0. Right? I could have left it with the original if I wanted. After I have it like this, I then choose to write a equals the sign in front of my y squared, which is 1. B is equal to minus 7. And C is equal to 12. And I will substitute it into my minus b formula. So my minus b formula is minus b plus or minus the square root of b squared minus 4ac over 2a. And that is on page 20 of your log tables. Sub the stuff in, so I get minus 7 plus minus square root minus 7 squared minus 4, 1, 12 all over 2 times 1. So when you multiply it out and tidy it up and stuff, minus by minus gives you a plus, so you get 7 plus or minus square root of 49 minus 48 over 2. Alright, so when you solve that, you're getting 7 plus and minus the square root of 1, which is 1, over 2. So that means I have 7 plus 1 over 2, which is 8, over 2, which is 4, or I have 7 take away 1 over 2, which is 6 over 2, which is 3. So they are my two values. Sorry, you've gone off the screen. Nope. totally lost it. Okay, so these are my two values for my letter Y. Okay, I will then take these two letters and plug them back into my X, so way up at the start. All right, so my X, I had X was equal to 7 minus Y, so that means my X is equal to 7, take away 4, which is 3, or my X is 7, take away 3, which is 4. All right, so that hopefully showed you how to solve your two different types of simultaneous equations. So again, if you have a simultaneous equation with normal terms, so x's and y's, and the other one with x squareds and y squareds or xy's, you solve it by substitution. So you rearrange one of your lines and plug it into the other. If you have an equation where it's just x's and y's or a's and b's and there's nothing funny with them, so there's no x squareds, there's no y squareds, there's no xy's multiplied by each other, you solve it by elimination. All right, so you match the things over each other, you multiply one of the lines so you get a plus term and a minus term, and then they cancel. So in terms of that, just make sure you get a plus and a minus. Okay, so that's that. Hopefully that worked.